All right, we're getting away from parallelograms. We're done with parallelograms. We dealt with rhombuses, we dealt with rectangles, we dealt with squares. Those are all types of parallelograms. These are not parallelograms. They are quadrilaterals, but they don't have two pairs of parallel sides. They have one pair of parallel sides or zero pairs of parallel sides. Uh, Kites have some congruent sides. They have pairs of congruent sides. I'll show you. Trapezoids have only one pair of parallel sides. And let me show you. Okay, so there you have a trapezoid. Now, okay, well, this is all about trapezoids. The non-parallel sides of the trapezoid are called the legs. Those are out here. The parallel sides are called the bases. Bases, legs. It doesn't matter. The bases are not always longer. In these pictures, the bases are longer, but sometimes the legs can be longer than the bases. The only thing that makes the bases is that they're parallel. Legs, not parallel. If the legs were parallel, then it would be a parallelogram because you'd have two pairs of parallel sides. Okay? Special trapezoid. Special trapezoid is called isosceles. Its legs are not parallel, but they are congruent. That makes for an isosceles trapezoid. If it's isosceles, then not only, you remember with an isosceles triangle, not only are the sides congruent, but the angles, which are called the base angles, are congruent. Well, it's the same with a trapezoid. If I have an isosceles trapezoid where the legs are congruent, just like an isosceles triangle, but now it's cut off at the top by a fourth side, just like with an isosceles triangle, the base angles are congruent. Same thing here with an isosceles trapezoid, the base angles are congruent. Only if it's isosceles, only if the sides, only if the legs are congruent can we do this. Then the base angles are congruent. Now the other thing that you're going to want to, the other theorem that you want to remember is this one on the bottom, which makes isosceles trapezoids like rectangles in that their diagonals are congruent. Isosceles trapezoids only. All right, how can we use that? Well, here's an isosceles trapezoid. They told us in the instructions it's an isosceles trapezoid. Find its angles given only angle S is 50. Okay, well, remember, if it's an isosceles trapezoid, those base angles are congruent. So what's angle S congruent to? Well, you can tell it's not angle P or Q. Those are obtuse angles, so it's got to be angle R. So angle R is 50. So measure of angle R equals 50 degrees. But then how am I supposed to come up with the rest of them? Well, here's a clue to that. You can always pause if you're about to think of it. Don't let me ruin it for you. But here comes the answer. So if that line goes on, and this line goes on, and this line goes on, and what these two lines are parallel, says so right here, then this looks like this line is a transversal. And if that line is a transversal, then alternate interior angles are congruent. So this is 50 over here. And same side interior angles or consecutive interior angles are supplementary. So angle P on the inside has got to be 130. I'll erase this to just make it more visible to you guys. But basically, if you've got two parallel lines and a transversal coming through them, then you're going to have the acutes be congruent to each other if the lines are parallel, and the obtuse and the acute are going to be supplementary, so angle P is 130. And since we figured out angle R was 50, angle Q, you can figure out in lots of different ways, is also 130. for a number of different reasons. What are the different reasons? Well, for one, it's an isosceles triangle, so P is going to be congruent to Q. For another, it's another transversal over here, and so therefore Q and R are going to be supplementary, and we already know that R is 50. For another, we know the other three angles. Angle R is equal to angle S, and so if you add 50, 50, and 130 together, you get 260. Excuse me, 230. You get 230, and 360 minus 230 equals 130. So a number of different reasons the angle Q is 130, and there you go. Okay, next example asks us figure out if this is a figure out if this is a trapezoid. Figure out if this is a trapezoid. Well, or show that it is a trapezoid. Well, we have to show that there's one pair of parallel sides. So we check the slopes. Okay, slope of BA goes down 5 over 5, right? So down 5 over 5. So the slope is -1, and that's for BA. What about CD? Well, CD goes down 3 over 3, down 3 over 3, so the same slope. So we just proved they're parallel lines. All right, but one thing we still have to make sure of, could this be a parallelogram? Could it have two pairs of parallel sides? We have to check these other lines. This is so BC is up 2 over 4. So now AD had better not be up 2 over 4. BC is up 2 over 4. And that reduces to 1/2, a slope of 1/2. So now AD better have a different slope, and sure enough, it does. AD is up 4 over 2. That's different, right? It's not the same slope, it's a different slope. So that pair of lines, those are the legs, these are the bases, and this is a trapezoid. We just showed it. All right, so that's enough for part 1. Part 2 coming in a separate video.